Hi, I'm Jay from the Sophos support team, and today I'll be talking about the fundamentals of Linux. Linux is an operating system just like Windows and can be used for a variety of tasks, but is often most used to handle server capabilities such as a file server, DNS, print server, and much more. What you commonly find with Linux machines is that they don't run a GUI. Doing so allows the server to be more efficient and delegate most of its processing power to its configured role. Since most Linux machines don't have a GUI, you'll be navigating it through the Linux command line, also known as the shell or terminal. The Linux shell is a text-based interface that allows users to interact with the Linux operating system by using commands. It provides a powerful and flexible way of managing and controlling various aspects of the system. Today, we'll be covering the Linux file system and its structure, file permissions, relative and absolute paths, commands and their syntax, and some useful tips and tricks. First, let's go over how the Linux file system is laid out. The file system starts with root, represented by a slash. Root is the highest level of the organizational hierarchy of the file system. Each system only has one file system, and everything else such as folders, external hard drives, and network shares are represented within it. At the next level of the hierarchy are a handful of specific folders, defined by the file system hierarchy standard. Home is where the regular user's home folders are stored. Root is where root's home folder is stored. Some of the other folders you may need to explore are etc, which is where most programs keep their configuration files, bin and sbin, which is where programs that the system utilizes are kept, and lib, where shared libraries and modules are stored. Now, we'll also want to be familiar with the long listing command, or ls-l. This is a useful tool for providing detailed information about each file and directory. It displays information such as permissions, ownership, size, modification date, and file directory names. When using the command, 7 columns are outputted, each providing different information. Let's break down what each of these columns means. File permissions and type. The first column represents if you are looking at a file or directory, as well as file permissions. This can be interpreted by the following. D at the front denotes a directory, a dash denotes a regular file, and L denotes a symbolic link. You may also see additional characters which can represent special file types. The second column shows the number of hard links to the file or directory. The third column displays the username of the owner of the file or directory. The fourth column shows the group to which the file or directory belongs to. The fifth column indicates the size of the file in bytes. The sixth column displays the date and time when the file or directory was last modified. The last column represents the name of the file or directory. Moving on, we'll look at file permissions. File permissions determines who can access a file or directory and what actions can be performed on it. Each file and directory has 3 types of permissions: read, write, and execute. These permissions are assigned to 3 categories of users: the owner of the file, the group associated with the file, and others, also known as everyone else. These permissions are represented by a series of 10 characters with the following format. Let's break down this structure. The first character represents the file type. It can be a hyphen for regular files, D for directories, L for symbolic links, and other special characters can be used for special file types. The next 3 characters, R, W, X, represent the owner's permissions, R for read, W for write, and X for execute. The next 3 RWX represents the group's permissions, and the last 3 RWX represents the permissions for others. For each category, owner, group, and others, if a permission is granted, the corresponding character is present. If it is denied, a hyphen is used. Now, let's cover what each permission allows. Read allows the user to view the contents of a file or list the contents of a directory. Write allows the user to modify a file or create, delete, or rename files within a directory. For directories, it also enables adding or removing files. Execute allows the user to execute a file if it is a program or script, or traverse into a directory and access its contents. To modify file permissions, you can use the chmod command. The chmod command is followed by the letter U, G, or O to specify if we're modifying permissions to the user, group, or others. a plus or minus to specify if we're adding or removing permissions, the permissions we're adding or removing, rwx, and finally the directory or file we are modifying permissions for. For example, chmod u plus rw file.txt. This allows us to grant read and write permissions to the user owner. Chmod g minus x file.txt. This removes execute permissions for the group. And chmod o plus r file.txt. This allows others to have read permissions. You can also use numeric notation to represent permissions. Each permission has a corresponding numeric value. Read is equal to 4, write is equal to 2, and execute is equal to 1. You can add these values to grant or remove permissions. 7 indicates full permissions as read 4 plus write 2 plus execute 1 equals 7. We need to specify a number for each, the owner, group, and others on a file or folder. For example, to grant read and write permissions to the owner, you can use the command chmod 600 file.txt. In this case, 6 indicates read and write permissions for the owner, and 0 removes all permissions for the group and others. Now that we've covered permissions, let's go over the differences between ownership and permissions. Ownership refers to the user and group that is associated with a file or directory. Every file and directory is owned by a specific user and group on the system. The user who creates the file becomes the owner by default, and the group ownership is typically inherited from the user's default group. The owner of a file or directory has certain privileges and controls over it, such as modifying permissions and changing ownership. Permissions, on the other hand, determines what actions can be performed on a file or directory and who can perform them. Linux uses a permission system that specifies access rights for 3 categories of users which we covered: the owner, the group, and others. These 3 types of permissions are read, write, and execute. Now, let's cover the differences between a relative and absolute path. Both are used to specify the location of files and directories. The key difference, however, is in how the location is referenced. A relative path is defined in relation to the present working directory. It specifies the location of a file or directory relative to your current position in the file system hierarchy. Relative paths do not start with a /. Let's use the following command as an example. In this case, documents is a relative path, assuming that you're currently in the home username directory. It specifies a directory called documents in home username. An absolute path, on the other hand, provides the complete and exact location of a file or directory from the root of the file system hierarchy. It specifies the entire path, starting from the root directory to the target file or directory. Absolute paths always start with a /. Here's an example of an absolute path. Home, user, documents. This path explicitly states the location of the documents directory within the path of home user. Now we'll go over the syntax of commands and how to structure them. Before we discuss commands and how to navigate the shell, let's look at how command line statements are structured. The general pattern that you'll see is command, options, and arguments. In this example, you can see some common commands that have an option and argument used in conjunction. Depending on what you're doing, you might have a command with 1 or more options or arguments. However, there will always be a command. A command is a program that you're running, or action that you're taking. In the first example, we have the command ls, which means list. It shows the files in a specified directory. Sometimes a command does something by itself. Other times we'll want to change how a command works or tell it what data to use. The next part of a command, the options, tells the command how to operate, changing the command's behavior or telling it to perform different actions. Most options start with a dash and are specified by 1 letter. Most commands also offer more than one option. For example, we can add the option -l to the ls command, which tells the ls command to show a long listing of the files in a directory rather than a shorter one. We can also add others, like -a and -h, which tell the command to show us all the files, not just the hidden ones, and to make the file size human readable. Most of the time, instead of listing each option individually, we'll combine them right after one dash with no spaces in between, like so. The only exception to this is if the option requires an argument. The order of options usually doesn't matter, so this will do the same thing. Options that have two dashes, however, cannot be combined and must go one right after the other, separated by a space. An example of this would be if you're trying to use the command grep to search for the string -i. Normally, using grep-i would tell the command to ignore case sensitivity, but for our use, we'll have to input the command as grep -i file.txt to indicate that we're trying to find an instance of -i within the file. The last portion of a statement is the argument or arguments. This is where you tell the command what to operate on. Generally, this would be a file path or a set file or folder. In this example, we're telling the ls command to show us the user bin folder's contents. Further down, we're telling the sort command to sort a file called users. That's it for the basic syntax of commands. Understanding this basic pattern will help you learn and use unfamiliar commands in the future. Now that you understand the basic structure of commands, let's cover some of the commands that you should know to navigate a Linux environment. It's important to note that unlike Windows, Linux is case sensitive. We'll be covering some of the commands that you should know to navigate the shell. For the rest of the commands, we've created a document that you can look at to either review or use as a reference sheet while working on a Linux machine, which is linked in the video description. As we discussed before, the ls command is useful in telling you the contents of a directory. By default, it will show the contents of the directory you are in unless you specify the path after the command. Variations that you can use with the ls command are ls-r, which will list all files in the subdirectories, ls-a, which shows hidden files, and ls-al, which will show a detailed listing and hidden files. cd is the next command and will let you navigate the Linux file system. Using the command requires either the absolute or relative path of the directory you want to switch to. For example, if we're in the root directory and want to switch to home, we'll simply use cd home. However, if we're in the root directory and want to switch to the user folder located in home, we'll have to input cd home user. Useful shortcuts to know with cd are cd ... which allows you to move one directory up, cd by itself to go straight to the home folder or root folder if you're logged in as root, and cd- to move to your previous directory. Now that we've covered the commands that you should be familiar with, let's go over some tips and tricks to make the process a bit more simplified when using them. You can use the clear command to clean the terminal if you find that it's cluttered with too many past commands. You can also use Ctrl+L as a shortcut to run the clear command. The tab button can be used to autocomplete commands that you are typing. For example, if you're changing directory to the Documents folder, you can type cd doc and click tab to have the terminal complete the command or directory for you. If multiple results match doc, the possible options will be displayed in the terminal. Ctrl+Z and Ctrl+C can be used to stop any command in progress. The difference is that Ctrl+Z will suspend the command, and Ctrl+C will stop and terminate the command. Commands can be sent to other commands by using a pipe. For example, using ls-l pipe grep -d will perform a long listing of the current directory, but only return directories. Chevrons can also be used to input and modify data. For example, we can use the command echo hello world write chevron file.txt to input text into a file. You can also use double chevrons to append data to an existing file, such as echo goodbye world double write chevron file.txt. As you'll see here, the data was added into the file instead of overwriting our previous text. Lastly, you can run multiple commands in a single argument by using a semicolon to separate them. For example, touch file.txt semicolon echo hello world write chevron file.txt semicolon mv file.txt home username documents. This command will create the file file.txt, place the text hello world into it, and then move the file to the documents folder. You can also use two ampersands instead of semicolons if you want the next command to only run if the first is successful. With all that covered, you should be able to navigate through a Linux operating system with ease. For further information, as well as additional training resources on the Linux operating system, as well as command references, view the links in the video description. For further assistance, view and post questions on community.sophos.com, and go to techvids.sophos.com for more great videos like this one. Thanks for watching!